Milwaukee M18 Fuel 3/8" to 1 and 1/2" ratchet threader is a cordless tool designed to efficiently thread intermediate metal conduit, often referred to as IMC. User experiences indicate that this threader offers a significant speed advantage compared to manual ratchet threaders, particularly when working with larger pipe sizes. The tool's construction features all metal components and a heavy-duty motor, suggesting durability in demanding work environments. The design facilitates one-handed operation, allowing for ease of maneuvering and control, especially in confined spaces. The cordless design enhances portability, making it convenient for transportation and use in various job site locations. The advantages of the Milwaukee M18 Fuel ratchet threader include faster threading speeds compared to manual methods. The durable construction contributes to a long-lasting tool life. The one-handed operation enhances ease of use. The cordless design provides portability and convenience. Potential disadvantages include a higher purchase price, approximately $500. Battery life might be a limitation for extended use applications. Cutting oil is necessary for proper lubrication during the threading process. As alternatives, the Ryobi 18 volts 1+3/8" to 1 and 1/2" ratchet threader is presented as a more budget-friendly option with similar functionality to the Milwaukee model, priced around $300. The Rigid 315 electric ratchet threader is described as a premium option, featuring fast threading speeds and a variable speed motor, with a price point around $1,000. When selecting a ratchet threader, several factors should be considered. Firstly, the frequency of use. If you are threading IMC frequently enough to find a manual ratchet threader cumbersome, but not enough to justify a professional-grade electric threader, the Milwaukee M18 Fuel 3/8" to 1 and 1/2" ratchet threader might be a suitable choice. It offers a balance of speed, durability, and ease of use. Secondly, the budget is a critical consideration. If the budget is a primary concern, the Ryobi model could serve as a viable alternative. Thirdly, threading speed and control is a factor. The Rigid 315 electric ratchet threader is a premium option featuring fast threading speeds and a variable speed motor, with a price point around $1,000. Additional considerations include the size and type of conduit you typically work with, the importance of portability, and the availability of battery charging facilities on the job site. When using any power tool, including a ratchet threader, safety is paramount. Always wear appropriate personal protective equipment, including safety glasses and gloves. Ensure the work area is well lit and free from obstructions. Before commencing threading, inspect the conduit for any damage or deformities. Use the correct size and type of threading dies for the conduit being threaded. Apply cutting oil liberally to the dies and conduit to reduce friction and heat buildup. Maintain a firm grip on the tool and conduit during operation. Avoid over-tightening the dies, as this can damage the threads. After threading, clean the conduit and dies thoroughly. Store the tool and accessories in a safe and dry location. In addition to the specific models mentioned, other brands and types of ratchet threaders are available. Research and compare different options to find the best fit for your specific needs and budget. Consider factors such as warranty, customer reviews, and availability of replacement parts. The choice of a ratchet threader ultimately depends on the individual's needs and priorities. Carefully weigh the pros and cons of each option before making a decision. Proper maintenance and care will extend the life of your ratchet threader and ensure its optimal performance. Regularly inspect the tool for any signs of wear or damage. Clean and lubricate the moving parts as needed. Replace worn or damaged parts promptly. Store the tool in a clean and dry environment. By following these tips, you can choose the right ratchet threader for your needs and ensure its long-lasting performance. When working with electrical conduit, it's crucial to adhere to the National Electrical Code, or NEC, and local electrical codes. The NEC provides guidelines for the proper installation and grounding of electrical systems to ensure safety and prevent electrical hazards. Here are some key aspects of working with electrical conduit according to the NEC. Firstly, conduit fill. NEC Section 344.22 specifies the maximum allowable percentage of conduit fill, which is the percentage of the conduit's cross-sectional area that can be occupied by conductors. The allowable fill percentage depends on the number of conductors in the conduit. For example, for one conductor, the maximum fill is 53%, for two conductors, the maximum fill is 31%, and for three or more conductors, the maximum fill is 40%. Secondly, conduit support. NEC Section 344.30 outlines the requirements for supporting electrical conduit. Conduit must be securely fastened to structural members to prevent it from sagging or becoming dislodged. The spacing between supports depends on the size and type of conduit. For example, for rigid metal conduit, or RMC, the maximum spacing between supports is typically 10 feet. For electrical metallic tubing, or IMD, the maximum spacing is typically 5 feet. Thirdly, grounding. NEC Article 250 provides detailed requirements for grounding electrical systems. Conduit must be properly grounded to provide a low impedance path for fault current to return to the source. This helps to protect against electrical shock and prevent equipment damage. Grounding can be achieved by bonding the conduit to the equipment grounding conductor or by using approved grounding fittings. Fourthly, bending. When bending conduit, it's important to use the correct tools and techniques to avoid damaging the conduit or reducing its cross-sectional area. NEC Section 344.24 specifies the minimum radius of conduit bends. The radius must be sufficient to prevent damage to the conductors inside the conduit. Fifthly, cutting and threading. When cutting and threading conduit, use appropriate tools and techniques to create clean and accurate threads. NEC Section 344.28 specifies the requirements for conduit threads. Threads must be clean and free from burrs to ensure proper connection. Sixthly, fittings. Use only approved fittings for connecting conduit sections and terminating conduit runs. NEC Section 344.42 specifies the requirements for conduit fittings. Fittings must be compatible with the type of conduit being used and must provide a secure and watertight connection. Seventhly, protection. Protect conduit from physical damage and corrosion. NEC Section 300.4 provides requirements for protecting conductors and cables from physical damage. Conduit should be installed in locations where it is not likely to be damaged by impact or abrasion. If conduit is exposed to corrosive environments, use corrosion-resistant materials or coatings. Eighthly, identification. Identify conduit runs clearly and accurately. NEC Section 310.11 provides requirements for conductor identification. Conduit should be labeled to indicate the type and size of conductors it contains. This helps to prevent confusion and errors during maintenance and repairs. Ninthly, workmanship. Install conduit in a neat and workmanlike manner. NEC Section 110.12 requires that electrical work be performed in a skilled and professional manner. Conduit runs should be straight and parallel, and fittings should be properly tightened. Sloppy or poorly executed work can create hazards and reduce the reliability of the electrical system. Tenthly, inspection. Have your conduit installation inspected by a qualified electrical inspector. NEC Section 90.4 requires that electrical installations be inspected to ensure compliance with the code. An inspection can help to identify potential problems and ensure that the electrical system is safe and reliable. By following the NEC guidelines and best practices, you can ensure that your electrical conduit installations are safe, reliable, and code compliant. The NEC is a comprehensive document, and it's important to consult the latest edition for the most up-to-date information. When selecting a ratchet threader, consider the types of conduit you will be working with. Different types of conduit, such as rigid metal conduit, electrical metallic tubing, and intermediate metal conduit, require different threading dies and techniques. Ensure that the ratchet threader you choose is compatible with the types of conduit you will be using. Some ratchet threaders are designed for use with multiple types of conduit, while others are specific to a particular type. Check the manufacturer's specifications to ensure compatibility. In addition to the type of conduit, also consider the size of conduit you will be working with. Ratchet threaders are typically rated for a specific range of conduit sizes. Choose a ratchet threader that can accommodate the range of sizes you will be working with most often. If you occasionally work with larger or smaller sizes, you may need to purchase additional threading dies or adapters. When threading conduit, it's important to use cutting oil to lubricate the dies and conduit. Cutting oil reduces friction and heat buildup, which helps to extend the life of the dies and produce clean, accurate threads. Use a high-quality cutting oil that is specifically designed for threading metal. Apply the cutting oil liberally to the dies and conduit before and during the threading process. Avoid using excessive force when threading conduit. Let the ratchet threader do the work. Applying too much force can damage the dies or the conduit. Use a steady, even pressure and allow the threader to gradually cut the threads. If you encounter resistance, stop and check the alignment of the dies and conduit. Make sure that the dies are properly lubricated and that there are no obstructions. After threading conduit, it's important to clean the threads thoroughly. Use a wire brush to remove any burrs or metal shavings. This will ensure a proper connection when you install fittings. Inspect the threads carefully to make sure that they are clean and accurate. If the threads are damaged or incomplete, you may need to re-thread the conduit. When installing fittings on threaded conduit, use pipe sealant or Teflon tape to create a watertight seal. Apply the sealant or tape to the threads before tightening the fitting. This will help to prevent leaks and corrosion. Tighten the fittings securely, but avoid over-tightening. Over-tightening can damage the threads or the fitting. Use a wrench or pliers to tighten the fitting. Be sure to use the correct size wrench or pliers for the fitting. When working with electrical conduit, always follow safety precautions. Wear safety glasses to protect your eyes from flying debris. Wear gloves to protect your hands from sharp edges. Work in a well-ventilated area to avoid inhaling fumes from cutting oil or sealant. Disconnect the power supply before working on any electrical equipment. If you are not comfortable working with electrical conduit, hire a qualified electrician. Electrical work can be dangerous, and it's important to have the necessary skills and knowledge to do the job safely. By following these tips, you can thread electrical conduit safely and effectively. With the right tools and techniques, you can create clean, accurate threads and ensure a proper connection when you install fittings. Remember to always follow safety precautions and consult the National Electrical Code for the latest guidelines and requirements.